Hello everyone, welcome back to my channel. Today's video is the second video of my video series, which talks about video and image generation using diffusion models and AMD GPUs. If you don't see my first video, make sure to check it out. I will leave a link in the top right corner and make sure to watch it first. Okay, today's theme is to talk about Wan2.2 5B model to use Wan2.2 5B model to generate a video. And the first thing we're going to talk about is we're going to spend a few minutes talking about how a diffusion model works. There are actually two processes. The first is forward process, which is the training process. And during the training, you add noise to image and ask the model to train the model to predict the noise. And the other part is a reverse process, which is denoising, which is inference. During inference process, you input into the model a pure noise, and in each step, the model predicts the noise and subtracts the predicted noise from the pure noise, and in the end you will get a clear image. Okay, the second part of this video is we're gonna talk about the prerequisites of the workflow. And the first thing we're gonna do is we're gonna install this config.ui KJ nodes through the config.ui manager. In the previous video, I just talked about how to install this config.ui manager. Make sure to check it out. And click in the config.ui manager, you just click custom nodes manager, and in the search box, you just type KJ nodes. And because I have already get it installed, so I will not talk about in the installation process. Just click the install button, and the config.ui manager will install the node for you. After the installation complete, the config.ui manager will ask you to, restart the Zulu config.ui, and you will get the node installed, because it will install some Python dependencies, so it will cost a few minutes. And the second thing is about downloading some models. The first model is the main model, the Wan2.2 text image to video 5B model, and the second one is a clip, and third one is the VAE. I have collected the download links, and I will include it in the editing area of my video. Make sure to download it first, and after the download, you should put the models under config.ui Zuluda and models folder. The Wan2.2 model should go to unet and Wan2.2 folder, and you should put the downloaded file here. If you do not have the folder, you have to create it yourself. And the clip model goes to text encoders, and you should put the clip model here. And the VAE model goes to this folder, the VAE folder, and Wan2.2, and you put the downloaded files here. And after you put all those files here, you should restart the Zuluda config.ui in order for it to recognize those newly added downloaded files. Okay, let's now talk about the whole workflow. It's a text image to video workflow. And when you're looking at a workflow, you should look at the key sampler first, because it is the center of the workflow. and it is the node which is responsible for predicting the noise and subtracting the noise from the pure noise, and in the end, after a few steps, it will get a clear video and through this latent. So, okay, let's get started, and we should look at the input first. The first input is the model, and you should add the node unet loader gguf, and you can add the node through nodes. You should click here, and in the search box you type unet loader, and you just drag it here. And because I already done it, so I will just delete it. After you choose the node, and you should choose Wan2.2, Wan2.2 text to video, 5B parameters, Q6 quantization. You should choose this model. And the second node you should add is model sampling SD3. It is actually the node which determines how many steps are spent for predicting the high-level noise, and how many steps are used to predicting the detailed noise. And 8 is the number that recommended by the official Wan2.2 manual. And you just add this node and input 8 and connect the model of this node to that of this node, and then connect the model to the key sampler. And the second and third input is positive prompt and negative prompt. First, you should add load clip node and choose the clip model here, and type you should choose 1, and device you should choose default. Default is the CPU. The load clip will load the model into the system RAM and do the calculation through the CPU. And here you should add the positive prompt and negative prompts. Positive prompts are used to guide the whole generation process. You should add some text you want to generate and input it here. And the negative prompt is the prompt that you should not let the model to confine to apply to. And this is the text that I recommend by the Wan2.2 5B model, and you can just input as I do here. And the last input is a latent image, and because it is the image to video generation process, so you should load an image. This is an image that are generated through Gemini using this text prompt, and you can do it yourself. And you should add this load image node first, and you choose the image you want to include and add it here. And the second step you should do is to add this resize image v2 node. Because my GPU is 6600 XT with a limited 8 GB VRAM, so I need to scale down the image to a much lower resolution. Here I choose 640 and 480, and you can input the parameters as I do here. And the next step is you should add CFZ, CUD, and toggle. I talked about this node in my first video. If you do not know this node, you should check my first video. And you should connect the both image here and connect the image to the start image of this node. This node is called Wan2.2 image to video latent. It is actually the node that generates 81 frames of empty latent, and also add the reference image to the empty latent. And because I want to use 16 frames per second So I just input 81 here. The first one is for the reference image, and the other 80 frames are 5 second, 16 per frame second video. So I just input 81 here, and batch size is default to 1. And then you should connect latent to this latent image of the key sampler. The key sampler parameters are here. It is actually recommended by the Wan2.2 5B model. And seed, this is a random seed, and you can choose random. Every time you run the workflow, it will randomize the seed, and the steps is 10. And if the generation quality is low, you should add more steps. Here I choose 10, and CFG is used to determine how the workflow should conform to the positive prompt. And the sampler name and scheduler, you can use my settings. And the noise, you must choose 1. It tells the key sampler the input is pure noise. You should denoise it. And let's look at the output of the key sampler. It is the latent. And here you should add another node. It is the third model we downloaded. And you should add the load VAE node and choose the Wan2.2 VAE safe tensors. And actually this model has 2 functions. The first is to convert the image, convert the reference image from pixel space to latent space, which is high dimensional vectors. And the second function is to decode, because the key sampler outputs high dimensional latent space data samples, so you just use the VAE model to decode it and output the image through this node. It is called the create video, and here you can choose the frame per second. You can choose other frames, but here we just use 16 frames. And the output, you should connect to save videos actually, and you can add this node, and the parameters you can use mine. And this is the sample result. It is generated through this reference video. Okay, let's give it a try and run it again. And you can press the run button. And here you can see the generation process has begun, because I already done the text encode, so the system just used the cached one, so they don't need to go through this process again. When you first run the workflow, you should see the green box around this area, and the whole process should run again. And here it tells you there are 10 steps actually, and it will spend actually about 5 minutes for this key sampler step, and another 10 minutes are used by this VAE decode. So we can wait a few seconds to see if it runs smoothly. And here you can check out the task managers, and you can see the model is loaded into our GPU, vram, and the GPU is actually working. You can see the percentage changes, Okay, you can also see the CPU is working too, and the memory, the system memory has a lot of data about this workflow. And the first step, it will take about 102 seconds, because it is the first iteration. It takes takes a little bit long, and the second should be lower. Okay, let's stop here and wait the workflow to run through. Okay, the workflow has run through its completion. It actually takes 23 minutes because the VAE decode actually costs a long time, costs longer time than expected. And okay, this is what I want to talk about today. And in the next video, I want to introduce you to a new set of node, which is called One Video Wrapper by KJ, and I think it's a good node set, and I will redo this workflow using One Video Wrapper. And I will upload this workflow to Google Drive for you to download, and I will add the download address of these 3 models in the editing area, and so you can download for yourself. And if you like this video, please like and subscribe. If you have any questions, please leave a comment below. And this is for today. Thanks for watching. Bye bye.